everyone. Today we are continuing into our factoring unit. Today we're going to be learning about factoring special cases. So it'll be really similar to what we learned about last time, but now we're just going to look at some cases that end up looking a little bit different. So first one is we're going to be factoring perfect square trinomials. So if you remember from our previous unit, that looked like this, where I have a plus b quantity squared. And just as a reminder, if I were, for example, going to multiply out y minus 5 squared, that would really be y minus 5 times y minus 5. So basically, I'm taking that y minus 5, and that exponent 2 means I'm multiplying it by itself. And so if I were to completely multiply that out, I'll do my double distribution. So I do y times y to get y squared, y times negative 5 to get negative 5y, negative 5y, and then negative 5 times negative 5 to get positive 25. And then I can combine my like terms and I get y squared minus 10y plus 25. So let's go ahead and get to some examples. I want to factor it, and I'm going to see if there's a pattern to my answers. So first, what we learned about last time, I want to multiply a times c. So here I really have a 1, so I want to do 1 times 16 to get 16. And I'm looking for two factors of 16 that multiply to 16, but then add to equal my b value, which is 8. So first there's 1 times 16, that doesn't add equal 8. 2 times 8, 4 and 4, and I see that 4 plus 4 does get me that 8. So from there I'm going to split the middle, so I'm going to bring out here. And instead of 8n, I'm going to have 4n plus 4n, then plus 16. Now that I have 4 terms, I want to go ahead and factor by grouping, so I'm going to pair these off. The GCF of my first pair is just n. The GCF of my second pair is 4. So my GCF goes out in front. N squared divided by n, I get n, plus 4n divided by n, and I get 4. My GCF goes out in front. 4n divided by 4, I get n, plus 16 divided by 4, and I get 4. And then my GCFs come into their own, so I have n plus 4 times n plus 4. Well, since I'm multiplying the same thing by itself, this is the same thing as n plus 4 squared. Okay, let's try another one. So first, I'm going to do a times c, so I have 4 times 9 to get 36. I'm looking for two numbers that multiply to 36, but then add to negative 12. Since I'm multiplying to a positive 36 but adding to negative 12, that means that these need to both be negative. So negative 1, negative 36, nope. No. Nope. But I see that negative 6 and negative 6 work. So now instead of negative 12x, I want to split that into negative 6x minus 6x plus 9. Factor by grouping. My GCF in my first pair is going to be 2x. The GCF in my second pair is going to be negative 3. That's because I don't want my first term to be negative. So when I take out my GCF, this is what I'm left with. And so I have 2x minus 3 times 2x minus 3, which ends up just being 2x minus 3 quantity squared. And so I see the pattern. If I am factoring a perfect square trinomial, I'll end up with the same thing. So I can just say it's the same, that's squared. Okay, go ahead and pause the video. I want you to try and just first factor out number 1. So what you should have gotten here was k minus 8 times k minus 8 equals 0. Now since this one is set equal to 0 and it's telling me to solve, I want to go and take this a step further by actually setting each factor equal to 0. But since these are both the same thing, I really just need to solve one and solve for k. So my answer here is k is equal to 8. Okay, this one I also want to solve, but if you remember from our last lesson, I need this set equal to 0. So that means I need to move both of these terms to the other side. So I'm going to subtract 12y and add 36 to both sides. Okay, go ahead and pause the video. I want you to try and complete this problem. So the answer you should have gotten here was that y is equal to 6.